Hello, this is Edmund Chen. I'm the principal investigator of the High Throughput Screening Resource Center. This resource center is supported by NRPB as a service to the nation for drug lead discovery through high throughput screening. In the next 20 to 30 minutes, I'm going to report to you on the following items. First, I will report to you the principle of high throughput screening as a vehicle to find the drug lead through screening. Second, I will report to you the facility that we used at the GRC. Third, I'm going to report to you the procedure that we used for the operation of high throughput screening at the GRC. And finally, I will tell you the item that we offer service to you, and also how you can contact us to get a service from us. The next slide is a simplified version to illustrate to you what, in my view, the high throughput screening can be used for the drug lead discovery. First, we needed to have an assay. The assay has to be therapeutically relevant and has to be able to perform in a small volume in high throughput mode. And then we needed to have a library. The library need to be a large number, need to have a large number of drug-like compounds, and it needs to be diversified. And with the library and the assay system ready, and the facility of the high throughput facility, and then we can do the screening. If everything goes all right, we should be expect to get a small number of hits. The hits are the compounds that has the expected reaction toward the target that could be potentially useful for therapeutic purpose. And after that, the hits has to go through the large number of studies involving chemistry and pharmacology to develop into more desirable chemicals that can be used as drug development leads. Now I shall use this slide to illustrate to you the major instrument that we use for high throughput screening and the function of individual instrument in the high throughput screening study. All instruments for high throughput screening are divided into two rooms. The right-hand side is for screening. The left-hand side is another room, is for hit picking. Let's start from the right-hand side. In the center of the room, there's a robot which does all the movement to carry assay plate from place to places in order to complete the assay. First, the robot will go to one of the incubators, which has many empty assay plates. The robot will pick one assay plate and bring to the dispenser washer station. Over there, there's the dispenser station will pump reagent or assay solutions or recombinant enzyme or cell lines into the plate well. When this is done, the well of the plate will contain all the assay solution for the assay. The robot will bring this plate to the pin tool. And the robot will go to the incubator on the left-hand side that has the compound plates. Will bring the compound plate also to the pin tool. Over the pin tool station, there is a pin tool head. The pin tool head has 1536 pins. Pin tool head will touch the compound plate using the 1536 pins. Afterward, the pin head will touch the assay plate again. By doing that, 50 nanoliter of compound from compound plate will be transferred into the assay plate. This completes the addition of compounds to the assay. After that, the plate is ready to do incubation. So the robot will bring the plate to one of the two incubators and incubate for a certain time, depending on the assay. At the end of the assay, the robot will come to bring the assay plate out and bring it to the Viewlux, which is on the left-hand side. The Viewlux is a multifunctional plate reader that can read all the results that our assay design. So that basically finishes all the high throughput screening online procedures. But we don't do high throughput this manner because the high throughput screening that we conduct is being done in 1536 well plates. So the degree of precision is very high, and every step must be correct. So because of that, we must practice and analyze every step, each step, and carefully. So doing that, we're using the offline station. Over there, as you can see in the bottom, there's a pin 2 station, there's a dispenser, which is identical instrument as the online instrument. Over there, we'll analyze each step and optimize each step, and to be sure that the assay is in a perfect condition. This is called assay development. Only after assay development, the assay is compatible for high throughput screening. And then we'll register by computer all the detailed assay conditions that we learned from the offline area and use the online area. And we'll do a real campaign for the high throughput screening over there and using all the compound plates. So at the end of this, so we have the hit. The computer will register the compound in different plate, in different wear positions about the hit compounds. And this information is transferred to on the left. Over there, as you can see, this room again has a robot, and there's 4 large chambers for compound plates. The robot will go to each compound chamber and pick up only the plate that contains 1 or 2 active compounds. And those plates will put it to the TCAN. And the TCAN liquid handling station will pick only the compound from the plate that are active in the high throughput screening. By doing so, at the end of this operation, all the active compound we find as a hit will be reorganized into a single plate by this operation in the hit picking. So this reorganized single plate hits will be used to confirm the result we found on the high throughput screening, and also the plate will be diluted. So we can do a dosage response curve to give a rank of the individual compound in the activity of the assay that we conduct. So that basically completed all the assay in the high throughput screening procedures. The next slide is a model of the high throughput screening room. As you can see, there's a robot in the center, the 2 incubators on the left, and close to us, there's 2 dispenser and washing station. Far end of this picture, there's a pin 2 station. And on the right hand of this is a compound plate chamber, and next to it is a Violax plate reader. This slide is the model of the hit picking room. Again, the robot in the center, there's 4 chambers for compound plates, and on top of that, there's a TCAN liquid handling station to organize all the hits into one plate. This slide has all the real pictures of the individual instrument that we are interested about. The number 1 is the dispenser washer. As you can see, there's assay plate sitting on the track. When the track moves, the dispenser will pump solution into individual wells. And number 2 is a pin tool. And here you can barely see there's an assay plate sitting there, also there's a compound plate sitting there. The pin tool head will stamp the compound plate first and then stamp the assay plate. Afterward, the pin head will go to the 3 washing chambers, washing tub, to wash them and dry them and ready for the next transfer of compounds. The number 3 picture is a Violax in the center, on the left hand of the photo, and the robot in the center. Number 4 is in the heat picking room, the TCAN liquid handling station that put all the heat into one place. The bottom of the slide is the photo, wide-angle photo of the high-throughput screening room, and the robot, and there's near us there's a pin 2 station. On the far end there's 2 dispenser. On the right-hand side, an incubator. On the left-hand side, a compound can chamber, and the Violax plate reader. Now let's talk about the compounds in your compound library. We have 2 sources for all compounds to put in the library. One is from commercial vendor. The other are collected from individual chemists in Taiwan. The commercial compounds has to be diversified, and also we want them to follow the Lipinski's rule of 5 to make them drug-like. And individual chemists make arrangement with us and agree to donate the compound to us. We have a separate agreement with them. When the compound comes to us, we first identify to be sure the identity of the compound are correct, and then the structural information and other properties of compound are properly documented into a database. Now, this slide tells you how we prepare the compound plates. Before I tell you the details how do we prepare the compound plates, I want to tell you in brief word the advantage of our high throughput system, because that is related to how we prepare the compound plates. In my opinion, there's two advantages for our high throughput screening facility. The one is economy, because we're using 1536 to conduct high throughput screening assays. Because the well is very small, each well usually contains about 5 microliters of assay total volume. Because the small volume is very economy for all the assay reagent, which is expensive, and also economy for the usage of compound, which is difficult to prepare for the compound library. So the economy is the one major advantage of our system. The second advantage is that the compound plates are located online. What I mean online is that the compound plate are seated next to the robot arm. So whenever we want to conduct a high-throughput campaign, we can just wake up the robot and start work. So the fast response is another advantage for our system. Because this is true, the fast response is great, but the compound sitting the room temperature online can be decayed. So after 6 months, we replace the old compound plate and replace with a fresh compound plate. By doing so, we need to have many copies of compound to sit in the freezer and take one every 6 months and replace them with fresh one when they are getting aged. So now let's talk about how do we prepare the compound plates. So when the compound comes in the powders, we individually, manually put them into 96 deep well plates and dissolve them in DMSO to be sure that the compound are completely dissolved. And then after dissolution, the compound are transferred to 384 deep well plates. By doing so, 4 of the 96 well plate will constitute a 384 deep well plate. And after that, the compound will dilute to 1 millimole, again into 384 plate. Here, we make 10 copies of the 384 well plates. 1 copy was put in the high throughput machine. The other copy was used to further process it, to make 7 copies of 1536 plates. And 1 copy of the 1536 plate was put in the high throughput machine. The rest of the 6 copies of the 1536 well plate are put in the freezer for storage. And so are the other 384 plate wells also put in the freezer for storage. By doing so, 1 milligram of the compound powder come to us. We can make many copies and estimate to last for 12 years. So this is another reason I said our process is a very inexpensive high throughput procedure. This slide tells you the contents of compounds in your library. We have a total of 2 million compounds in our library. The library will divide into three parts, A, B, C, 3 sets. And for high throughput screening to the service of NRPB project, we think that to screen 2 million compounds is too slow and also is too expensive for most users. Because of that, we select from each set of compound. We divide the compound into many categories. And from each category, we collect several compounds to the represented library. So the represented library represented the entire library because all the skeletons in the entire library are present here. In addition, we also have all the known compounds or known drugs, the APIs, are present in the represented set. So in year 2011, our represented set contains 113,934 compounds. And because another purpose for this resource center is to maintain and improve the compound library. So every year we make a significant effort to synthesize additional more unique compounds and collect any additional compound that we can purchase that are known drug or APIs of approved drug. we add this compound to the existing library and also put it into the representative set. So in year 2011, we add another about 4,000 compounds to the library, also to the representative set. So the current representative set called representative set 2012. This one has 118,000 compounds. This is the compound library that we use for the high throughput screening to the service for the NRPB projects. In the previous slides, I report to you mostly on the technology aspect of our high throughput services. Now I'm going to tell you some administrative aspect of our service. First, the mission statement. As an NRPB resources center to support the research programs for biopharmaceutical discovery by identification of drug leads skeletons from the GRC chemical bank using the GRC high throughput screening facility. Our operation have 3 parts. The most of them are the services. The service can be offered to high throughput screening services for NRPB projects and also for non-NRPB project service on high throughput screening. Our technology improvement jobs including the enrichment of the GRC chemical bank and high throughput screening technology developments. We also have a collaborative efforts in the medicinal chemistry for high throughput screening leads, collaboration for high throughput screening for drug discovery, and also have assay development collaborations. This chart illustrated the organization or operation in the service-related and the R&D jobs. As I said earlier, that our resources center is supported by the NRPB and NRPD also provide guidance for our operation. The high throughput screening operations, including the assay development, the high throughput screening, and the compound library maintenance, all of this are under the supervision of user committees. If we have to make any major change for our operation, we have to get approval from the user committees members. And so as you can see, the operation including assay development and high throughput screening. And the result of high throughput screening may end up with leads. The lead could go to the collaborative effort in chemical synthesis, and we also maintain the library by collecting more compounds or synthesize more compounds to enrich the chemical bank. So those are the operation and organization of our service center. This slide illustrates the contact information that you can get a service from us and the items or services we offered. On the right-hand side corner of this slide, as you can see, that's listed the high throughput services. We do consultation, and we also serve pre-screening meetings. And if your high throughput screening is a cell-based assay, we can help you grow a large amount of cell for all the development and screening. And for cell-based assay, your assay format will be modified and changed, optimized into the high throughput screening format. And this is assay development for cell-based assay. If your assay is a biochemical-based assay, we can also do the assay development to optimize the assay and to make it a high throughput screening compatible. And when the assay development was conducted successfully, and then we'll do either cell-based high throughput screening for you or biochemical-based cell high throughput screening for you. And those high throughput screening campaigns will result in hits. We'll cherry pick the hits out and confirm that, and we're using IC50 determination, either cell-based assay or biochemical-based assay, to rank the hits. And that conduct all the technical aspect of our studies. And then we'll provide the report for you, and then have analyzed the results. In this report, we'll tell you everything that we did for you, and as well as the compound structure in the hits. And afterward, we'll have a service to answer all the questions that you may have. Now, how can you get the service from us? You can follow those simple steps to contact us and obtain services, and we'll answer all questions that you may have. First, you can contact us for a consultation meeting. In the meeting, we'll understand each other and your high throughput screening objectives. What is the target of your screening? And we'll tell you our facility and how we operate the facility. Number 2, we'll have a technical meeting with you. In this meeting, we'll discuss about assay reagent, the cells, the control compounds, and the reporting systems, and also the payments that you may want to provide. 3, based on your prototype assay, we'll develop high throughput screening assay for your project. In this case, we'll provide a service team of 2 or 3 persons designated for your project to transform your assay to a 1536 well automated assay. 4, when this is done, we'll conduct high throughput screening for your project. We'll screen about our representative library of about 150,000 member library for your targets. When this is done, the hit will be identified. We'll do cherry picking to find out the hits and identify it and organize them in a single place. And then we'll confirm. Next one, we'll confirm the hits activity, and then we'll do IC50 to rank the potencies. Finally, we'll provide a report to the user. After reported, then we will provide post-high throughput screening discussions in the following 6 months. During the 6 months, you can ask us questions, we'll answer you. And we can assist you or collaborating further medicinal chemistry studies to continue your projects. So, high throughput screening is mainly conducted in the technical aspect, assay development, high throughput screening to identify hits, and then the hit will be confirmed and the ranking for the potencies. I'll use this slide to illustrate those technical aspects of those studies. The slide A is an example we did before for anti-flu screening, anti-flu drug screening. So in this assay, we'll find out in the left hand of the wells, you'll find out the cells only. Every well has the same amount of cell. As you can see, the point of this one is the uniformity, that all the cell growth is the same. There's no major difference among the different wells, so they are uniform. When the cells are alive, they are uniform grow in all situations. When throwing virus to the cell culture, as you can see on those wells on the right-hand side of this, that they become black, that the cells are all killed uniformly. So the point is now we want to have uniform cell growth, uniform virus killing, and the contrast between the virus killed culture and the intact cell, there's big gaps. So the signal are very different. Signal noise, a clear tail, the live cell versus the killed cell. And the next question is, how can we provide an assay that's predictable for finding unknown compounds, inhibitors for the antiviral? So again, here we have to use a control compound. Here we use Tamiflu, that is a known anti-influenza virus compound. We add a different dose of Tamiflu to the wells. And as you can see from bottom to the top, there's a gradient decrease the protection of the virus killing. When you have a high concentration of Tamiflu, there's a better protection, as good as the no virus infection. When you have less Tamiflu, the protection getting less effective. So the image for the figure A can be transposed into figure B to quantify that. As you can see, the dot on the top of the figure, those are control cell only. As you can see, the activity of the cell are all high. And then the bottom rows are those killed virus cells by introducing virus to it. As you can see, the signals on those virus-treated cells are much lower. And the contrast between the live cell and dead cell is significant difference. And then there's 3 groups of dots with different doses of Tamiflu added to the virus infected cell culture. As you can see, there's doses depending protection of the virus killing to the cell. So after this is done, then we can say the assay development was successfully done, because we have an assay that can clearly tell the significance between the live cell and dead cell. And in addition, if the compound has a predictable activity, we can tell that. In other words, if your assay can find hits from our library, this assay have a potential to identify this compound for you. When this is done, the next one is moving to high throughput screening campaign. Figure C shows you that the majority of compound has no activity for this assay, as you can see. Only a tiny amount of compound shown in the arrow that has a high activity. That's fit the criteria to define them as a hit. So we picked every one of those compounds from our library and then confirm it. And after confirming them, we do different concentration dilution of the compound and do a dose-dependent assay as shown in D. As you can see here, different compounds have a different dosage responsive curve. And from the dosage responsive curve, we can deduce IC50. That will be used as to rank the potency of the hits. So we hope this IC50 value will be useful for the user to determine which compound they prefer to study further or not. So that basically concludes all my technical report for you on the all high throughput screening, the administration type as well as the technical aspect of a report. Finally, I'm going to introduce a short movie that shows you the high throughput screening instrument in action. So goodbye, and come to see us for questions, and we'd like to get your service for you.